Without a doubt, one of the biggest issues I hear from people when getting into CNC is not understanding feeds and speeds, and that is exactly what we're going to cover in today's episode. I'm going to talk to you a little bit about the theory. I'm going to tell you some tools that you can use to help, and worst case scenario, the technique that I use to dial my settings in whenever I need to. But first, now, as we work through the video today, one of the biggest issues that you'll see is there's just not enough data for desktop CNC machines, and ultimately this is why people struggle. Now, to try and get around this, I'm in the process of developing an app that is going to make it very simple. You select your machine, you select the bit, you select the material, maybe even the spindle, and it's going to give you a very safe working range for your machine. Now, whilst I am most of the way there, I do need some community help just to make this app as accurate as possible. So if you're already familiar with your machine and some feeds and speeds, there is a link to a very quick form down below where if you could just share a little bit of your information with me in terms of your feeds and speeds, I can cross-check them against mine, make sure everything is okay. And as a thank you, I'll give you a link to some project files I have never shared with people before. So let's move on and talk about the theory, and hopefully with this very large end mill I can show you how it all works. Now, what I am going to say before we dive in is calculating feeds and speeds can get very complex. Now, I like to keep my videos simple, and that is exactly what I'm going to do. I'm going to hopefully give you just enough information that you understand it without making it too complicated and showing you all the different variables that can impact it. So hopefully you'll stay on board, you'll stay interested, and it's going to help you out. So let's set up and I can talk to you about speeds, chip loads, and all the things that go with it. Now, the more you understand about the theory, the easier it becomes later on. But don't worry if you don't understand anything at this phase, because it will become clearer the further that we do go through. Now, there are three machines in front of me here. The smaller SaintSmart one is arguably the stronger, more rigid frame overall, but it has smaller motors. The Fox Alien, bigger motors, faster motors, but is belt driven, so it lacks some torque. Then we've got the long mill, somewhere in between, lead screw driven, pretty powerful, pretty rigid. You will also notice we have a router, we have a 400-watt spindle. Now, the problem is, it doesn't mean that if we run this one speed on this machine and put the router in that machine, we can run it at exactly the same. There are too many variables going on. We have to adjust and account for the overall setup as opposed to just the spindle or the bit itself. And this is why it starts to feel slightly complicated, but we're going to simplify it as we go through. Now, the next thing we're about to talk about is the bits themselves, and something you may have heard of called Chipload. Now, don't worry, when most people talk about Chiploads, they get into doing calculations. We are not going to do a single calculation today. So let's talk about my big blue tool. Now, here I have a 2-flute upcut end mill, and this is basically just a magnified version of that to try and highlight some of the things about the bits and the way we get to this thing called a chip load. Now, in its simplest terms, the chip load is however much material is being excavated or removed by your bit when it spins and cuts through the material. Effectively, how much it is scooping away each time it does a rotation. Now, when it comes to the bits themselves, there are multiple factors as part of this. The amount of flutes that it has, the angle that it is cut at, all of these can play a part, even things down to how deep this is in your collet. If it is in quite shallow, that's going to be stiffer than if it is out quite long, and there's going to be more deflection in the bit itself. Now, as I keep saying, it's all these things that make it feel very difficult to find this correct rate for your bits. Now, when we are talking about chip load, there is what we call an ideal window. Now, a lot of people don't realise that if your bit is going too fast, it will overheat. But equally, if it's going too slow, it will also overheat. And whenever your bits start to overheat, you're effectively dulling them and losing the cutting edge, which means they have to work harder to do the same job. And that's what we're trying to avoid. We're trying to make bits last as long as possible. And we achieve that by getting in this ideal chip rate or this ideal feed and speed range for the bits themselves. So in its very simplest form, it is how fast can we move this bit through the material without it overheating. Now, I just want to touch on that point in a little bit more detail. When we're talking about desktop machines or budget-friendly machines, it is rarely the bit that is the problem. It is usually the machine itself, either a lack of torque from the spindle and rotors and the stepper motors, or just having a little bit of flex on it. That is why often you'll go into the tool databases for these bits and see speeds that may seem ridiculous to you. That is what the bit is capable of, but as I say, the limiting factor is your machine itself. It doesn't have to have a huge amount of flex. For example, the long mill, pretty solid frame, it just has the tiniest amount of wobble, and that means your speeds and feeds have to come down significantly. Just as an example, something like a 1/8 bit, fairly thin, on the right machine, that will cut through 1/2 inch plywood or even 3/4 inch plywood in one single pass at speeds like 50, 60 inches per minute. Now you put that same bit into one of these machines and you've got to drop that depth of cut drastically, probably to only the thickness of the bit or a couple of millimeters deep. And that is ultimately, as I say, because of the limitations of the machine, not necessarily the limitations of the bit itself. Now I am very conscious that I've mentioned what feed is, basically the physical rate your bit is being pushed through the material by the machine. But I've not actually really touched on what speed is and why that is important. So for those wanting to understand a bit more about the calculations and terminology, I'll try and explain it as simple as I can and hopefully get it right. Now, when we are talking about the speed, it is what's actually known as the SFM, the surface feet per minute, or meters per minute if you are metric. Now, the way we achieve that figure is, well, I find it easy to think about your bit being horizontal instead of vertical. Now, obviously your spindle has an RPM, a revolutions per minute, and your bit also has a diameter or a circumference. Now, think about something simple like 3 RPM, 3 revolutions per minute. Imagine putting your bit on a flat surface and rolling it 3 times. We go 1, 2, 3. Now that speed that I referenced, or the surface feet per minute, is the distance from point A to point B. And ultimately that figure allows you to calculate what the bit is capable of cutting. Now obviously bits with a larger diameter would have a higher SFM, or surface feet per minute, and bits with a smaller diameter would have a smaller SFM. And that is why it's important. It's more about the surface the bit is travelling as opposed to the rate your machine is pushing the bit through the material. Now at this point, a lot of people start talking about calculations, and they start saying things like times the diameter by the amount of flutes, divide it by the RPM, multiply that by the speed of light, and a whole lot of factors that just start to make this confusing. Now this is no disrespect to machinists. They are very intelligent people that work to, a set of defined calculations and rules that actually work. But the problem is they end up coming out with a calculation that tells you a bit like this should be able to cut up to 4,000-5,000 millimeters per minute. The problem is the machines don't travel that fast, and this is ultimately why it starts to become a problem, because the optimal speeds that this should be running at, the machine can't necessarily achieve. Now, as I said earlier, we're not going to do a single calculation on this video because I've never done them myself, and that wouldn't be fair for me to try and suggest that is what I do. It's probably killing a lot of machinists out there. I'm probably going to get some very negative comments for not running through all these calculations, but ultimately it's not the way I learned, so why would I try and teach a way that I didn't learn myself? Now what I am going to show you is some tools that will hopefully get you in a close enough range to give you confidence. Now what we're about to see is some feed and speed calculators that take into consideration certain elements like the type of spindle or router that you have, but don't necessarily factor every element in about the machine that you are using. So as I say, they will get you close, but you may have to do some tweaking yourself. Now I'm about to show you 2 apps on a phone and 1 on a computer. Now they all have pros and cons, so it's about finding the right one for you. But let's start with the Millwright app. This can be downloaded from the Google Play Store for free. What I like about this is it's relatively simple to get from the start to the end. The downside to this, it is quite minimal in the options that you have within it, and it's only really designed for their own machines. Now when you come to use this, I would suggest selecting the M3 range, which I think is their lowest option, probably closest to a normal desktop CNC machine. But as we run through, it's pretty simple. You basically select the size bit that you want, the amount of flutes that it has, whether you want to be conservative, normal or aggressive, put in the RPM range you want to run at, and then the material, click calculate, and it's going to give you the feeds and speeds that you can run at. It will tell you the feed rate for it, as well as the ideal depth of cut. This is a key thing that a lot of things miss out. They will tell you the feed rate, but not the depth of cut, which is obviously vital to what we're doing. Now, the other downside to this app as well is it can only do end mills. So if you want to use something like a ball nose, a V-bit, a tapered ball nose, well, ultimately, this is not going to be the one for you, but it is ideal just for doing end mills. Next, we're going to switch over to FS Wizard. Now, the advantage to this is it has more variables that you can change for different controls. For example, you can select different type of bits in this if you wanted a ball bit, for example. However, its downside is that it's probably more for metal machining than CNC woodworkers. And what I mean by this is it basically gives you one option for wood, just wood. No softwood, no hardwood, just wood. Now, anyone who knows anything about wood, obviously there is an entire scale in terms of the hardness of the different woods that you are using. And something at the top of that scale is going to be a lot harder to machine than something at the bottom of that scale. So that is probably its biggest limitation. But let's quickly run through it. Now, what I will say is at the top of the screen is where the vital information is that you need. And as you work through the process, all those figures update at the top. So you basically select the material that you want, which is unfortunately just wood. You would then select the type of bit that you want, which is a solid end mill or obviously a ball nose. Go in, put the details in, like the diameter of it, the amount of flute, and you also have extra detail on this, such as the angle of the helix. Now, you may not know this, and if you're unsure, just put something in like a default value of around 30. You can then go into further detail, such as the whether you're cutting a slot, whether you're doing something like a pocket where you have a step over, because you can even control the feeds and speeds for the different elements of that. And as I say, as you update these, all the information at the top will be displaying on the best guess for this for your machine. But one thing I should have mentioned at the start of this app is it doesn't account for the machine type. So that is another downside to it. Next is onto the computer, and this is called HSM Advisor. Now, one of the things I like about this is to some degree you can allow for the profile of your machine. Firstly, you can create a profile by going to the top right hand corner, putting your machine in there. Now, you can put things in such as the RPM range for your spindle. But the other thing I like about it as well is the material library. Whilst I imagine it is still primarily for metal, when you get down to the bottom, you do have a range of plastics and acrylics as well as wood. You've got hardwood, softwood, plywood, MDF, so you do get a nice range within there, which obviously helps narrow down your speeds and feeds that you need for the particular material. Now, it is very simple to work through. Again, you have a couple of options, such as whether it's an end mill, a ball mill, even again down to the material that you are using, whether it's carbide, HSS, and you can also put in the number of flutes, as well as obvious things such as the diameter of the bit itself. Then when you come further down, you can control the depth of cut that you want to run at. Now, obviously, if you haven't realized already, as you change these settings, obviously it all impacts the output for the feed and speed rate. So if you want to go deeper, obviously that will impact the end rate. And if you want to go shallower, again, it all works together. So you can control these all individually, as well as the width of the cut, which I mentioned on the last app, whether you want to do a straight slot cut or something like a pocket cut where you're doing step overs, all can be controlled within this. So it is quite nice to be able to do this, but you've got this extra little box over here. Now, the reason I like this is if you know, for example, your machine isn't particularly the strongest, what you can do is allow for that in this. Take the slider bar down just a little bit to account for it not being as strong. Or for example, if you have a belt driven machine that doesn't have as high a torque, you can reduce this down for allow to it. And ultimately it just keeps adjusting these feeds and speeds. And I should point out, this is probably my favorite because it gives you enough adjustment in what you can control without making it feel overcomplicated. So as I've already highlighted, there are a lot of variables in this process, and even if we try to put the exact same settings in all three of those applications, you're probably still going to get different end results. Why is that? Well, probably because the applications are making certain assumptions about the machine we're using or the material. For example, the one just classified all wood as wood. Now, what do you do at that point? Well, the honest answer is you have to test. And this is how I basically dial my settings in for the machine, not necessarily the bit that I am using. Now, when you come to do tests, I do something like this. You don't see it much in the CNC world, but you see it all the time in the laser community. They call it a power scale grid. And it's ultimately about just doing the same test over and over again, but either increasing the speed or increasing the depth. Obviously, you start very conservative and start to build your way up. Now, when you're doing one of these tests, it is really easy. Just do multiple squares in your software, and as I say, either increase the settings one by one and just run them through step by step. Now, pay attention to the quality of the cut, but also listen to your machine as well. It will start to tell you when it's working too hard. It will sound a lot more aggressive. You may also get something like a constant thud, a do 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 do. This is basically called chatter, and it's the bit bouncing, which means it's going too aggressive for what the machine is capable of handling. But as I say, also the quality of the cut will tell you, and the final thing is the wood chip itself. Now, the reason I've left this till last is because when a lot of other people talk about it, they just go, oh, you need a good chip, and they show you a fairly decent sized chip that they're able to get off their powerful machines. Now, the problem is, if you're on something like a 3018 machine with a low powered spindle and a 1/8 bit, your wood chip is probably going to be what they consider to be dust. It doesn't necessarily mean it's a bad wood chip for that machine, and this is my point. It has to be relevant to the machine you're using. Now, don't get me wrong. If you're working through that process that I just mentioned, you should see a difference in the size of the chips themselves, and ultimately you want a good quality chip or a bigger chip than something like pure fine dust. So the scale is still applicable no matter what size the machine is, but almost the size of the chip is relevant to the machine that you are using it. And if you're not getting like a big good quality chip like you sometimes see others producing, well, it is probably because of the size of your machine and the spindle that you are using. It doesn't mean that it is wrong. As I say, it's all about the relevance of your machine with that bit, as opposed to trying to compare it to others with bigger or different machines. So hopefully speeds and feeds don't seem as scary as they may have done at the start of the video, and you now have the processes and tools to get you in a much better position. And as I mentioned at the start of the video, if you do have experience and can input some data into the app that I am working on, please do so. It's not only going to help me, but obviously the entire CNC community, especially beginners starting out, because they're the ones that struggle the most. I do hope you found the video useful, and of course, any comments on the way that you work things out for your speeds and feeds, do let me know in the comments section down below. Thank you all very much for watching. Final thanks as always goes to my patrons, and I'll see you all on the next episode.